Hello. In this series of videos, we are using Psychopy and Python to create the line-bisection task. Now, in the previous video, we did a lot of background and a lot of sort of setting up of our workflow and of our getting an idea of just what it is that we're trying to do so that we can now start really coding in Python the experiment. If you haven't seen the previous video, it's fairly long, I'll admit, but it takes you through a nice gentle pace, and it should bring you up to speed, eventually bring you up to speed with what it is that we're trying to achieve here. Now, if you have seen that previous video, you'll note that I have converted all of our stimuli distances into the number of pixels, because remember we figured out the pixel density of our monitor. And so what we've got here is that a 36-degree visual angle stimulus presented at 47 centimeters away gives us a 30.5 centimeter long line, which then when we convert that into pixels says, hey, we need 1112.66 pixels for this particular monitor to present that stimulus. Now, we're going to run into a problem in a little bit because, hey, what's 0.66 of a pixel? You either have a pixel or you don't have a pixel. And so you can see here that this is a number that we have to block down into an integer, into a whole number. Relax, we can do that really easily in a little bit. It's not a problem at all. So I've already calculated for all of our stimuli distances and sizes and line widths and this and that. We now know how many pixels we need to put into Python or into Psychopy to then present the correct stimulus. So we're now shifting gears a little bit into creating our program, into the Python programming. And so what we're going to do is we're going to shift our workflow and everything just a little bit so that we can have access to the documentation. So remember, this was the where we got the information for the monitors. What we're going to do is we're going to close that down and we're going to start to use the documentation from Psychopy. And so if I now hit this command and then the plus arrow, I'll make that nice, a little bit bigger for you. So hopefully you can see that. What we want to do is we want to get the reference manual. We want to get the API. Now, if you wanted to use the builder program that Psychopy comes with, hey, run for your life. No, that came out wrong. Sorry, go for it. Sorry, go for it. I have no issues with that at all. What I like to do, as I said at the end of the last video, is I like to have control over every single part of my program. And so therefore, I can trust what goes in there. Now, that's just my approach. If you want to use the builder, unfortunately, these videos are probably not for you, and that you can probably try and look for some other help somewhere else. We're going to code this thing from scratch. Okay, we're also going to learn a fair bit of Python programming as well, and so that could help you if you're doing a PhD, or if you're doing a master's, or if you're just interested in neuroscience-y sort of stuff and you want to say, hey, can we do some programming with Python and push around visual function and all that sort of stuff. I think it's super cool. So we've got the reference manual on the right. We're going to use this again and again and again to say, hey, how do we tell Python or how do we tell Psychopy to do this? We need it to do this. We need it to do that. What is it? What are the words and what's the syntax that we need to do to plug in, okay? So as you can see here, we've got psychopy.core, and that will give us the basic functions, the clocks. Psychopy.visual, it will give us the basic visual stimuli. So we're going to use those two. We're not going to use tools. We're probably not going to use data. We are probably going to use logging because Psychopy is really good at saying, hey, you want to present this stimuli for 15 frames or something like that. Okay, for this certain duration. And hey, when I calculated the frame timing, it said, hey, 3 of your frames were really long. And so therefore you might have a problem with your video card. And so it's going to log all these errors. We're probably going to come into a lot of those errors because I'm using a really old Mac here. And I'm also using OBS to capture an external monitor, and I'm looking at this. So what I'm going to do here, at my own risk, is turn off all the logging except for the most critical ones. How do we do that? Well, we've now just clicked onto the API of the reference manual and we've gone to psychopy.logging. Now again, excuse me for looking to the left or to the right as you see it, because that's where my monitor is currently located. So I'll put that there so you're not going to miss anything out. So this is the doc string at the top of our program. We're going to go to the end of that doc string. And remember, here's where we imported our stuff. So a single line comment, we use a hash. And so we'll import some help. Import some help. Now I haven't viewed the first video file that we've got, that we created. And so if there's errors there, it's going to be a fly by the seat of your pants sort of affair here. We're going to clear the command output. So here we're just commenting what it is that we're doing. Now we don't need any of this because we know that the pixel density is 36.48, I think, from memory. Let's have a look at our command prompt output, 36.43. So if we split the difference there, it's about 36.45. So let's just go 36.45 pixels per centimeter. Okay, so we can clear that. I'm just getting rid of the muck that we had before. So we need to import some help from the libraries. And so we imported the OS library, and that's what we did to create this one-line code command output. Clear the command output. Now we need some help from Psychopy. So what we're going to do is, see here we've got an overview of what this certain function or this certain library does. And then it says, hey, if you want to use it, okay, this is how you use it. So we can literally just cut and paste this. Copy, we'll put that into here, we'll hit paste, and there we go. We have now done our first bit of Python coding. Now, if you're new to Python, you might want to say, hey, I want to write everything down myself. And hey, you go, girl, you go, boy, you do what you need to do. Over time, you'll get bored with copying and writing everything because, like me, you might start making lots of mistakes. And so cut and paste is your friend. I don't want that second line of code directly underneath the importing. We're going to space it all out. So I'm just going to Command V that. And so therefore clear the command output, and we're going to set the logging to critical. So here we go. Logging.console.setLevel. Okay. It's logging.critical. So what does critical mean? So if we look now here at the documentation, we look for the parameters. It says set level, new level, set the minimum level for the log file stream. And so that's great. Okay, so critical means of a letter critical or higher. So Python has, Psychopy inside it has a sort of a set level that it has, like, this is a real big failure. You know, you're going to lose really critical timing or really critical errors. Really bad things are going to happen. If it's tagged as that sort of error, then it will log that. If it's something similar like, hey, I couldn't quite get the red channel to go perfectly to 98.9% red or something, you know, that's who cares, all right? And so it will just ignore that. It won't log that. And so there's a lot of different functions that you could call here. You can go logging.flush, and that will, you know, flush all the logs. You set the default clock and all that sort of stuff. So we're using just a very simple .set level here. Okay, so that will set that. And so what we might want to do is just print out here, hey, Psychopy logging. Oh, I wrote looming there for a looming task. Logging set to, and it's set to critical. Okay, so that's just a little reminder to us to say, hey, you've set the logging to critical there. So if we run this program again, it said, hey, Psychopy's logging is set to critical. Now, the other thing that we might want to do at the start of our program is to get the date and the time. So what we might do is say import date time, okay? Or what we might want to do is say from date time. Now, these come with Python. Date time comes with Python. Remember, you will need to import the Psychopy. Not import, you will need to download and install Psychopy onto your correct path. From date time, import date time. And so now if we print this here, we can then print under that date time dot now. And so hopefully what that will do is print out the current date and the current time. So you can see here, I'm running this currently on the 27th of February, yes, 2020 at 11:53.33.0.286 seconds in the morning. And that's correct time for Hobart, Tasmania, where we currently are. Okay, so just so we know, hey, when we're doing things, we can get rid of that later. We might also want to use this timer here when we log event presses or it log something from our subject. Okay, so it's not going to be a bad thing for us to just know what time it is that we're dealing with. So this is right at the top of our experiment. We haven't declared any variables yet. We're just sort of setting things up. And the other thing that I want to do right at the start here is I want to print out, hey, what is it that we're doing? So it's going to be the line bisection task, and it's based off Kim et al. So line bisection task version alpha. It's no release here. And so here what we've got is just a little reminder to say, hey, look, this is what we're working on at the moment. Okay, and Python, and then what we'll do is we'll print this right at the bottom as well. Oops. Okay. And so it's just a little something at the start to say, hey, look, you know, visually, this is going to be the start of this experiment. Okay. Now, what do we need to do? Well, we've set the logging. What we need to do is think about, well, what's our experiment again? Well, our experiment is to present some stimuli. And so we need to present a fixation, we need to present a stimulus, and we need to present a mask. And then we need to do that again and again and again and again and again. Well, we need to do that 40 times for each block. And we need to do 4 blocks per session and 1 session per day. And each session should take 7 minutes. Now, if what I've just said doesn't make any sense to you, go back to the first video. We've pulled all that information out from that Kim et al. Paper that is at the back of this monitor here. Okay, so we need some stimuli. We need some canvases. And so let's get the information for that. So reference manual, let's go to psychopy.visual. And so this is where our stimuli will hide. And so from Psychopy import logging, and we're also going to import now visual. Okay. So how does Psychopy work? Very basically, what we're going to do, it's a bit like JavaScript when you create a canvas, for instance. What we're going to do is we're going to create a canvas and it's going to be created in memory, computer memory. And what we can do in this canvas, we can set the size of the canvas in pixels or centimeters or visual angle, okay? We can set the screen where that canvas will eventually appear. Screen 0 is usually the screen that's attached to your computer. Okay, in this case, it's a MacBook Air, so this is going to be screen 0. Python does zeroth counting, which means that it starts at 0 and then works its way up. If you're using MATLAB, it will start at 1 counting, so the first number in an array or in a counting is going to be 1, 2, 3, 4, 5, whereas Python, it starts at 0, so it's zeroth counting. So this screen here that I'm looking at attached to my laptop, that's screen 0. This screen here that I'm capturing and everything is being presented on, that's going to be screen 1. If you've got any other external monitors attached, hey, good for you. They're going to be screen 2, screen 3, screen 4, screen 5, okay? So in computer memory, we're going to create a canvas, okay? We can set the color as well. And so we need a window object. And then onto that window object, we're going to draw our stimuli. Okay, so we create the window, we then create our stimuli, we then draw that stimuli onto the window. It's still in computer memory. And then what we do is we flip that computer window from memory onto the screen. We're going to hear this again and again and again. Draw the window, draw the stimuli onto the window, flip window onto the screen. So there's going to be 2 steps to every stimulus presentation at least. A draw command, so draw it onto the window and then flip it from memory onto the screen. Draw, flip, okay? That's the basic approach. And so we need to create a window object onto which all of our stimuli will be drawn. And so here, Windows and display devices. So if we click here, this is the main class to display objects. So I've just clicked on that and here we go. I'm just going to command down arrow that a little bit. And so here, psychopy.visual.window. These are all of the functions or all of the parameters that we can set to our window. There's a lot there, I'll admit. We don't need all of that. We just need a small amount of that. So in our experiments, we only need a single window. Okay, in some of my other experiments, I've needed 3 or 4 windows so I can update the experimenter and update the experiment and do all this other stuff. We just need one window for us. That will do us. So let's create the window object. How do we do that? So now all I'm doing is I'm just going to pretty much take this. I can control cut and paste this and then paste it into this window. But there's a lot of stuff there that we just don't need. It's too complicated for us. We're going to use the minimum. That's the bare minimum. The absolute bare minimum of these parameters. And so I've got this locked up in my head. But just follow along, okay? Have a look here. If you want to know what any of this does what does full SCR mean? Equals none. Well, if we go down here, it should have it here somewhere. Let's have a look. Size, apply, aspect, blend mode, call on flip, clear buffer, close, color space, cover. No, we've gone a little bit too far, I think. Let's have a look back up here. Screen, units, monitor, windows, full screen. There we go. Are we going to create a window that takes up the full screen, or is it just going to take up a small part of that screen? There's some important things in terms of resource allocation if we tell it it's a full screen or not, okay? So all of the various parameters information is written underneath. Okay, so let's create our window object. We're going to call it win0. It's very original. So our window object is going to be equal to, let's go up a little bit. It's going to be visual, where am I? Let's go back here. So visual.window, capital W, okay? Now, the reason why we're not talking about this, the reason why we're not including this Psychopy at the start is because we've already said, hey, we're going into the Psychopy, and then from that, we're going to import logging and visual. So we don't need that first part. Okay, so visual.window. And so now we need to say, how big do we want this to be? So eventually we do want it to be full screen, but we're just going to play with a smaller area at the moment. So size equals, now this is going to be a tuple, which means we need to give it 2 parameters. We need to give it an X and a Y, or a width and a height. So let's just make it say 600 by 600. What? 600 watts. Well, we want to use the units of pixels, because remember, we've converted everything into pixels. Okay, so that will be the next thing that we need to put in here, and you'll see in here, you'll have units. There we go, units. Okay, so that's another thing there. Or you probably can't see that, but anyway, I've highlighted units. So the size is 600 by 600. So now what we want to do is we want to say, okay, well, where do we want it to be? Do we want it on screen 1 or screen 0? And so we want it to be on screen 1. Okay, now, what else do we want? Well, the other things that we're going to need is we will need to say, okay, now, in Psychopy, if you want to calibrate your monitor, so if you're doing some contrast experiments or you're doing luminance experiments and you've got a spectrophotometer and you've calibrated just how bright the monitor is, and you've measured the distances and the pixels and all that, and you've got a sort of, a calibration file, you can go into the test monitor center or the monitor center, and you can give it all that information, and then it will save that file and says, okay, you're running a Dell 24H19 or something, so these are all the values that you need for that. For ours, we're not going to calibrate, we're not going to do any lookup tables or anything like that. We've already sort of hard-coded and calculated all of that information for us. So what we're going to do is we're going to just use a test monitor. It may come to bite us in the bum later on, and so we may need to go into the monitor center and set things up properly in terms of viewing distances, but for our purposes here, we're just going to use the standard test monitor, default monitor. Okay, and so what we're going to do is we're going to say monitor equals test monitor. Okay, now you can see here that we've gone past this vertical line here. Now in Python, you get about 80 characters wide according to the style guidelines before you should start a new line. So the way that we can start a new line here is we just hit enter and it will just go on to the next line there. Not a problem. Monitor, we do need a comma underneath that though. So screen equals 1, the monitor equals test monitor. Okay, so full screen equals false. It's not going to be a full screen. Now, the other thing is, have a look here. We've got our window here, and have a look up here. We've got this toolbar and all these sort of minimize, close, and maximize parts. On a Windows machine, you have the same thing. And so what you can do here on Python, on Psychopy, is you can allow those GUI elements to stay or to go. And so that's allow GUI. We're going to say true. We want to see that, okay? Because then that should give us access of closing down that resource when we need to. When we go full screen and we do this experiment for reals, okay, we will then disallow that GUI, and it will take off the top, and it will basically just present a full canvas there. Okay, now what we need is we need to set a color. Okay, so how do we set the color? So here we've got color up there, so color. Now for my American friends, you can use your normal spelling. For my Australian and English friends and New Zealand friends, drop the U. It's American spelling, unfortunately. Now remember, this takes a red value, a green value, and a blue value. And we want everything for this window to be white. And so we go maximum red, maximum green, maximum blue. Remember, they're encoded from -1, which is nothing, to +1, which is 100%. Play around with it when you get a chance. Just see, hey, what happens if you do, set, say, the red channel to 100% and the green channel to nothing and the blue channel to nothing as well. Well, you'll get a red channel, you'll get a red monitor. Okay, what else do we need? Now I'm just reading here, win type, units, none, gamma, none, blend mode, none, screen. We've set the screen is going to be 1, multi-sample, number of samples, stereo, none, none, none. I think we've pretty much got everything that we need. Because we are running a smaller window in a bigger window, we can also set a position, and we'll set that position to 0, 0, and so it should appear dead bang center of our screen. And so that's this position value here. Position, it takes an array, location of the top left corner of the window on the screen in X and Y. Okay, so we'll put the top left corner of that window at 0, 0. Great. So there we go. We've just drawn our window. We've just created our window object. It's in memory. And remember, how do we put that from memory onto the screen? Well, we've just drawn it. So what we can do now is go win0. So remember, that's the name of our window object. Okay, we want to draw our window onto the screen. Okay, win0. Remember, flip. Win0.flip. So we draw onto the window. That's in memory, and then we flip that window onto the screen. And so we literally just go win0.flip. And if we run this program now, okay, we run that program, we should see a white 600 by 600 pixel window appear very briefly on the screen. Okay, there we go. Did you see that? Should be on the top left. That's where 0, 0 is. And so there it is. Okay. That's the window that we've just created. What we can do now is we can make the window appear for a bit longer. Okay. So we need to now start doing some timing. Okay. How do we get some timing information? So if we go back to our reference here, we go from visual. We don't want many visual stimuli. We actually want to do some timing. And so if we go to core here, psychopy.core, basic functions, clocks, etc. And so we've just clicked on that. And what we want to do is we want to wait for a certain amount of time. And so here we go, psychopy core.wait, and it accepts 2 arguments, the number of seconds. Okay, so it's in seconds, not milliseconds. That's good to know. So it looks like what I was saying in that last video. This is actually seconds. Okay, and time.sleep might be milliseconds. Anyway, so core.wait is in seconds. And so how do we get it? We need to import the core. So from Psychopy import core. And now what we want to do is we want to go core.wait. And then in here, we want to wait for, say, 2 seconds. Okay. And then once we've waited for 2 seconds, so that goes into there. What we should always do is to clean up after ourselves as well. Okay, so we tidy up. It's the polite thing to do. Tidy up our resources. Now, if you're using a lower level language like C or C++ or C#, something like that, Fortran or Algol or something like that, you would have to, once you've stopped using a resource, you would have to then destroy that resource. Otherwise, you'll just overload your memory or you'll get some memory leaks or overflows or something like that. In Python, it usually does it all for us. So once the resource is not needed anymore, it will tidy up that resource. But it's a good habit to get into closing everything down for yourself. And so what we'll do is you go win0.close. And that basically means, hey, look, we don't need that anymore. Close it down, destroy it in memory. We don't need it. So if we go here, we now run that program. We should see that white screen again. It should last for about 2 seconds or so. Okay, 1, 2, and then it should turn off on its own accord. Okay, now it is running a bit slow because, again, remember, I am capturing the external monitor as well. Okay, but that did it all itself. Okay, once we've done that, we could do a print. Okay, a program and window closed. And so we're doing, like, again, in JavaScript, like a console.log process here where we're just logging, hey, what's happening in our program at this time? Okay, so we've got that window there being shown. Okay, we're waiting for that 2 seconds. Then what it's done is it's said, okay, program and window has now closed. Brilliant. Great, so that's our monitor. So if we now say, put that as 0.5, we put this as at like negative 0.5. So we're just changing the color. Okay, we can now change the different parameters of our window object. And so I don't know what color this is going to be. Okay, so it's a nice sort of orangey, yellowy sort of color. Okay, and everything's worked well. Okay. All right, so we'll set that back to 111, 11111. All right, so that's our window. And what it's doing is it's just basically flipping onto the monitor once. We're waiting 2 seconds and then we're closing things down. Okay. What we want to do is we don't want to wait. What we want to do is we want to present that stimulus. We want to present that window for as long as we want. Okay. So how do we do that? What we're going to do is we're going to create a while loop. We're going to say while true. Okay. So while this thing is true, we're going to win0.flip. So we'll go Control X or Command X, Command V. We'll flip onto the screen and then we'll print something like, okay, flip. Okay, and so if we run this program, we're going to get into an infinite loop because we've got no way of coming out of that while loop, because that while loop is always going to be true. So you can see, there we go, flip, 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 flip. Okay, and so it's going to stay there forever and ever and ever until somehow the magic of the world, it will then make it false. And so here, how do we break into this now? What we're going to do is we're going to go Control C. What we'll do is we'll go into that and we'll hit Command or Control C. So highlight your command prompt or your terminal, hit Control C, and we've done what's called a keyboard interrupt. We said, hey, let me break into there nice and quickly. So if you run into problems and you want to try and get access back to your program, Control C. And that should keyboard interrupt. Okay, because we did a bad thing here is we created a loop that was always true. Okay, and it was never going to stop until, say, the power ran out or something like that. What we want to do is we want to start to get control over the stimulus presentation, just very generally. And so what we want to do is we want to, every time that wind is flipped, we want to check out what's happening on the keyboard. Okay, and so how do we do that? So we go back to the Psychopy reference manual, and what we want to do is we want to look down here. Hey, is there any way that we can look for key presses and mouse clicks? Clock, hardware, IO hub, tools. Maybe it's in tools, data, event. For key presses and mouse clicks. So if you look in event here, we might be able to wait until a key is pressed. So Psychopy event.mouse. So we don't want to do mouse button clicks. We want to look for key presses. And so here we go. Same as Psychopy event.getTease, but halts everything including drawing while awaiting input from the keyboard. Okay, great. And so here what we need to do is we need to now import event. So from Psychopy, import event. So now we have access to these functions. And what we want to do now is we want to say, okay, how do we run this program? I'm just going to cut and paste this. So copy, and we'll paste this into here. Command V into our loop. All right, it's gone past that vertical line, so we'll clean it up a bit. Okay, and so now what we're going to do is we're going to say, okay, we'll create a variable called key, and into that key we're going to pass in the value of the key that has been recorded. And so what it's going to do is it's going to wait infinitely long. That's correct. We don't want it to time out. Modifiers we don't need. Timestamp we don't need. If we wanted to do any timing, we would create our own timers. Clear events. True, yes, we want to clear the events from the buffer. And so here we've got our minimum list, our minimum parameter, sorry. But what we want to do is, because remember, our subjects are stupid and idiots and they're going to do everything that they can to break our experiment, we don't want eventually for them to destroy our program by accidentally pressing a different key and having that do something. So what we're going to do is in this line of code, this event.waitKeys is we're only ever going to listen out for the F key, the J key, or remember the Q key. And we can set that here. So the key list, so how do we make a list in Python? Square brackets with every item in that list separated by commas. So we want to listen for the Q button, we want to listen for F, and we want to listen for J. So if they press something other than that, nothing's going to happen. But what we can do, okay, so again, we've gone a little bit too far there. So we'll put that there. We want to say if now Q in key, remember, this is what's being listened out for. Okay, so when this, if any of these key lists are pressed, it will then put it into this key here, this variable here. So if Q was pressed, what we want to do, okay, is we want to break out of our program. Okay, and so the way that we do that, we just say break. Okay, and so since it's broken out of this while true loop, and it's put us from this indentation here back to the parent indentation, and basically it will quit out for us. Let's see if that is true or if I'm telling lies to you. So now what we would expect to see is the window to appear, flip to be written once, okay, this flip here to be written once, and then for nothing else to happen. Oh, okay, inf is not defined. Oh, okay, right, so I've given it something naughty. So Psychopy said, hey, look, the default value is going to be infinite. So if we didn't pass any value into there, it would wait forever. What we'll do is we'll wait for, say, 600 seconds, okay? That's not a problem. So here you can set a timeout. Said it's only going to wait for 3 seconds, or it's only going to wait for 30 seconds, or half a second, or something before it then breaks out. So here we go. It's flipped onto the screen. We've printed out flip once here. Great, brilliant. And so now if I hit the space bar, nothing happens. If I hit H, nothing happens. See how I hit J there? I accidentally hit J. It's actually returned something there on this event.waitKeys, because remember, the J is one of the values that it will listen out for. We haven't decided what we're going to do with it, but it has returned a key value there. So there is something in key. And so that means that we're going to return back to this top of this while loop and print out again. Okay, we're going to use that later when the subject says, hey, the left was longer or the right was longer. Okay, so hit the J. Oh, I'm on that screen again. We'll come back onto I'll show you the window. There's the window there. We'll come back onto our command prompt, hit the J button. Make sure that you have the window as the front window, because that's what it's listening out for, and it hits the J. So we learned a lot of things there. Hit the F button and it's doing the same thing. Hit the space button, nothing's happening, space bar. I hit the letter Q, okay, and then it's broken out. So here we go. We've now got some very brief control over the experiment, the timing of the experiment and stopping the experiment, and we've used a while loop for that. This is going to change slightly, but this is going to be essentially our main program loop. Loop will go here. Okay. So we want to do something a certain number of times. Okay. I've deleted that win0.flip. Okay. And we draw our window onto the screen. Okay. Control Command X, we'll put that there. Okay. Now, what do we want to do at the start? We want to create our fixation cross, don't we? And so one of the ways that we can create that fixation cross is if we go back to Psychopy here, we look for visual, many visual stimuli. What we want to do is we want to create essentially some lines to show a line. Or we want to show some rectangles, some very small rectangles. And so what we're going to do here is we will create for our fixation cross a line. And we're going to create two lines, a horizontal line and a vertical line, okay? Or will we? Let's have a bit of a think here. Let's have a look at the rectangle, because maybe we can just make very small rectangles here. Yeah, we'll actually use rectangle because in this rect stimulus, we can give a width and a height and the line width and the units and the color space and the size. Okay, so what we'll actually do is we'll actually use this rectangle here. So what we want to do is we'll create our fixation cross. Now, what we could do is we could create this on the fly, which means, hey, create the window, create the horizontal part of the cross, put that onto the window, create the vertical part of the cross, put that onto the window, and then flip that window onto the screen. Now, if we're going to do some very simple things, that's probably okay. The CPU of the computer is probably good enough to do that. What I'm going to do, however, is I'm going to put everything into functions, and so this is a bit more advanced now. And so what we're going to do is we're going to define a function. We're going to say fixation cross. Okay, and so in this function, we will create our cross. Fixation cross. And so any time that we then write fixation cross, it will then call that function, and that function will then return and do its thing, okay? And so what we need to do is we need to create our cross, the actual stimulus, the fixation cross. So we want the fix cross horizontal line equals, now we want visual.rectangle, because this is the stimulus that we're going to use. It's going to be a very skinny rectangle. Not a very tall rectangle, but it's going to be quite long. Okay, and so what do we need? We need to say, okay, we need to put it onto a window. So the window that we want to put it on is win0. Remember, that's the name of our window object. Okay, so we go win0 is the window that we want it on. Now the width. What width do we want it to go on? Now, the width, not colon, we've already calculated that. We calculated that in the first video. The width of the fixation cross is going to be 2.99 pixels. So we can't have a 0.9 of a pixel, so we're going to round up to the nearest number. And so we'll say that that's 3 pixels. Okay, and that's going to be 3 pixels. Okay, and so therefore our width is going to be 3 pixels wide. Okay, and our height is going to be 1 pixel high, because remember, it's going to be long but not very tall. Okay, height. Now the units is going to be pixels again. What color do we want it to be? Now, the line color is going to be, so line color equals, it's going to be black. Now, because we're using a rectangle, if we had a very big rectangle, you would have a line color, but then also a color that fills the inside of that. And so we've got these two parameters that we can play with. One of them is called line color. The other one is going to be called fill color. You can see that here, line color and fill color. And so our fill color is going to be, again, black. Okay, so here we go. Make sure that you have the capital C for color, okay, and that you've got the correct spelling, capital C for color there. So that's our horizontal line. Let's have a look now at our vertical line. So I just go Command C to cut that. We'll go back here and we'll paste this across. Whoops, let's go back here. Command V, and so this is no longer horizontal. This is going to be vertical. Let's shorten this. Let's just call this horiz and vert. Now, for the vertical line, we don't want a long width. We want it to be very narrow. So the width is going to be 1 and the height is going to be 3 pixels. Okay, just have a think about what we've done there. Now, we want to actually put this in a certain position, don't we? We want this position. Okay, where do we want that to appear? We want it to appear directly in the middle. Oops. We're going to change the position values later on when we change the transected line, but we just need to know, hey, we need to have it in a certain location in that window. So we've got these two we've got these two stimulus objects, the fixed cross horizontal line and the fixed cross vertical line. They're rectangles, but we've made them squished down. So now remember, how do we do it? We draw the stimuli into memory, we then flip the memory onto the screen. Draw, flip, draw, flip. Okay, so fix cross horiz dot draw, and so this will draw the horizontal bit onto the window, but it's still in memory. We haven't flipped it yet. Okay. And fix cross, not horix. We want horiz. Okay, and vert dot draw. Okay, and so what's going to happen is it's whenever we call fixation dot cross, whenever we call this function here, okay, it's going to execute everything that's at the next indent across. Okay, and so it's going to draw and it's going to prepare everything in memory. It's not going to flip it onto the screen until we flip it onto the screen, okay? So here, what we've done is instead of having to write all of this code again and again and again, whenever we want to draw the fixation cross, all we have to do now is we just have to say, hey, fixation cross, please, and then it's going to do all of that drawing for us, okay? And so if we now go when0.flip, but if we go now, we want to present the fixation cross. All we need to do is call that function. We've called that function fixation cross like that. And so now if we run this program, okay, so the fixation cross function is only going to draw it into memory because that's all we've done. Okay, and then we will then flip it onto the screen. Okay, and so now if we go into our program, we go line task. So now hopefully we should see a black cross in our window, and there it is. Oh, you can see it. It is super tiny. Can you see it? Ooh-wee. That's way too small. We'll just artificially make this bigger for us. The fixation cross, we don't care how big it is. It's just a orientation marker for our subject to say, hey, look here, and then keep your eyes here, okay? But as you can see here, it's staying there. We've drawn it onto our screen, okay? I then hit F, okay? And J, it's doing all of its things, okay? And then I hit Q there, and the program has come out, okay? Now, the reason I hit F and nothing printed, like what we did before, is because I've taken out that print statement. Okay, so let's make this a little bit, let's make it say 12, and we'll make the height 12, okay, just to see if we can see it, okay, and so this should be a little bit bigger for us to see, he said. There we go. So that's a pretty cool little fixation cross there. I think you can see that there. Let me just shift this microphone across a little bit. Sorry if that's very loud. Okay, so there's our fixation cross. Brilliant. I'm just going to hit Q, get rid of that. The program has now closed down. Great. So there we go. Let's change the color of the cross. Okay, so it's black now. Let's just make it like a weird color. Okay, and we'll make this a different color. Okay. Just to see what happens. You know, play around with your program. See what you can do. See, hey, let's change the position. Let's change the width. Let's change the height. Let's do crazy and funky things with it. You know, what happens? Oh, okay, so there we go. We've got now a very, I don't know if you can see that, but the horizontal part is actually yellow. And the vertical part is I don't know, it's a green. Very strange color. But anyway, that's our fixation cross. I'm going to hit Q again, and we're going to get out of there. Okay, get out of there. It's my Arnold Schwarzenegger impersonation. All right, great. So we have now created our fixation cross, and we've put it into a function. Oh my goodness, we're doing some really fantastic programming here. All right, fixation cross, win flip, key, event.wait keys, if Q and key. Okay, well, let's now draw our actual stimulus. Okay, so above our main loop, let's actually define our stimulus. So let's put line stim. Actually, let's just make a bisected line first. So bisect line. Okay. So here we are creating a bisected line only. So remember, bisected line is one where we've got a horizontal line, and then the vertical line is perfectly straight in the middle of our line. Only Poloni. Well, this is good because we've already created the basic bisected line with our fixation cross. So we don't need to write any more code. We can just cut and paste it and chuck it into here. Because remember, our line has our bisected line and our transected line has a horizontal bit and a vertical bit. We just have to change the lengths. And so what we'll do here is we will pass into this function a length parameter. So length. So line length. Okay. And so what we'll do is the width will actually be the line length. Okay. And the height, remember the height is always fixed. Okay, and so the height will be, how tall are our stimuli? So the vertical line is always 2.2 degrees visual angle, which is 65.84. And so if we now convert this into an integer, the way that we could do that is to write int 65.84, and then that will convert that. We'll just do this by hand, and so we'll just round it up to 66. 66 is a very nice number. It's a round number, so it's going to be 66 pixels tall. Now, so that we don't go into our different functions and we don't, start changing things that we don't want to change, what we can do in Atom is, you see here, I'm just hovering on the left-hand side here next to the line number. I click there. That's then going to go, and it brings it all up and it hides it all for us. And so bisect stim, fixed line horizontal. Now the line length, we will need to pass that into this function at some point. Now the vertical line is now going to be, I forgot how tall it was. What is it? 66 pixels. So it's going to be 66 pixels tall. Okay. Now, the height of our stimulus now, remember, it's how tall it is. We've actually got that. We've got that value because remember, when we pulled apart the information from the Kim paper, they said every line was, the thickness of the lines were 0.1 degrees visual angle. And then when we calculated that out, it was 2.99 pixels. And that equals 3 pixels. So now we know that every time we have a line, we need to set it to be 3 pixels wide or 3 pixels high, depending on if it's horizontal or vertical. And so here, for our stimulus, creating a bisected line only, the height of this is 3 pixels. The width of the vertical line now, remember now we're talking about the vertical line, it's going to be 66 pixels tall, but it's only going to be 3 pixels wide. Oh, that's 33. Brilliant. So now what we can do is we can pass, instead of the fixation cross into our stimulus, what we won't is we'll call this bisect cross horiz, and then bisect cross vert, bisect cross horiz, and then bisect cross vert. Okay. So it's just going to draw it. It's not going to put it onto the screen. Remember, we haven't win0.flipped. But let's just give this a shot. Let's just try and draw this. Bisect stim. So we're going to call this function. Okay, and we're going to run it. Now, some of you smart cookies out there are going to say, hey, there's going to be a problem. Where is the problem going to be? That's right. We haven't given it that parameter. It says, hey, you've tried to call this function, and it's missing one of the required positional arguments. What the heck does that mean? Well, remember, we've given it an argument here saying, hey, whenever we call bisect stim, we need to actually give it, oh, well, how long is that line going to be? And so in this case, what we're going to do is we're just going to pass it just one of the line lengths that we had at the start. Remember, Kim used one of 5 line lengths, starting from 36, going up to 40 degrees visual angle. Okay, and so in this case, we will pass it just a simple 36 degree visual angle. Okay, and so we'll round this to the nearest whole number, to the nearest even whole number. So we'll go 1112 pixels. Okay, you can calculate what percentage error this is going to be in your own time. So we'll just give it an even pixels, okay? And so whenever we draw this bisected stem, we have to give it 111, oh, I forgot, 2, is it? 1112. Yeah, so we'll just present for this early preliminary file 1112 pixels, and then this value here, when we call the function, it's actually being passed 1112, and then you'll see the width of this line here will eventually be 1112, and then that's what's played onto the screen. So here, hopefully, if we've done everything right, Command S will get rid of that blue circle up the top there. We've given it the correct numbers of positional arguments, i.e. 1, and we've given it the length of the line in pixels, and it was 1112, and so therefore, there we go. There is our stimulus. And then you say to yourself, well, hang on, Andrew. It's disappeared, excuse my chair, it's disappearing out the left and out the right. What the heck is going on there? I'll give you a chance to think about that. That's right. How big is the canvas? How big is the canvas that we're giving to present that stimulus on? That stimulus is there. It's actually presented all the way out there, but we're only presenting how big? Let's hit Q to get out of that. Remember, we're only presenting a 600 by 600 canvas. So what we should do now is we should probably run full screen. Let's go 1920 by 1080. Okay, now that it is full screen, we'll hit full screen equals true. And we'll just see what happens. I just Command S then to save everything, and we'll run it. If we've pleased the programming gods, it should say, okay, here we go. All right. So what it's done, now there is a bit of an issue here. Now, when I'm running my Mac, okay, it's basically converting, and there's a problem with Psychopy in that it's going onto my main Mac screen and not onto my external monitor. So what I'm going to have to do is I'm going to have to set full screen to false. Okay. And so that should hopefully get rid of this problem. Now, in your final implementation of this program, you'll obviously set it to full screen and everything should work well. Okay, so there it is. There's our stimulus. Huzzah, we did it. We now have a 36-degree visual angle. So if I'm sitting 47 centimeters away, I've now got a 36-degree visual angle stimulus being presented with a 2.2-degree vertical component to this stimulus. And this vertical part is slap bang in the middle of my visual field, but it's also slap bang in the middle of the left and the right. It's perfectly bisected. We've set it at 0, 0, which is directly in the middle. How can we test for that? Well, what I'm going to do is I'm going to get a piece of paper now and a pen, and I'm just going to draw, right? Just make a mark at the end of this, at the left side of the stimulus. So you can't see what I'm doing here, and the right side here. So as you can see there, there's the left and there's the middle. And I'm just going to put that onto the other side there, and I can tell you right now, okay, that there is pretty much bisected. That line, the length between the left side and the right side of that line, is bang on dead center. I hit Q, and we're back playing with our command prompt. We have now created, or we now have the ability to either present our fixation cross or our stimulus. Hey, let's actually do that just before we finish off. Okay, let's do that. Right, so we've got fixation cross, we've got bisected stim with the line length. Okay, so let's present the fixation cross. Okay, and we'll win0.flip, because remember, every time we draw a stimulus into memory, we then have to flip it onto the screen. And then what we're going to do is we're going to core.wait. How long was that stimulus, that fixation cross, presented for? For how long? And so therefore, we go back up to our cheat sheet up here, and it said, okay, the fixation cross was presented for 1000 milliseconds. And so what we'll do is we'll go, okay, we want to draw the fixation cross, we want to then flip it onto the screen, and then we want to wait for 1 second. And then what we want to do is we want to draw our stimulus. So we're drawing our other stimulus onto the window in memory, and then we're going to flip that onto the screen. Okay, so now we've drawn our fixation cross onto the screen. Okay, and then that's going to be flipped. Okay, so now we draw our stimulus. In this case, it's just a bisected line onto the screen. So we present the fixation cross. So we'll actually do this. So we'll draw fixation cross onto the window in memory. Okay, and then we flip window onto the screen. Okay, and then this does what it says on the box. We'll wait for 1 second. Wait for 1 second. Okay, that's fine. And now what we do is we draw our stimulus onto the screen, onto the window. And that's in memory again. Okay, and then we draw it onto the screen, and then we have to wait for an amount. Oops. Now for this, we're just going to use the very crude way of doing that, and that's core.wait. Okay. What we will do in an advanced video file is we'll convert all this into frame counts, so that you can get really exquisite frame timing. In this case, we are just going to present it for a certain core.wait duration. So how long does it take? How long does it last? So the stimulus is presented for 100, it's at 0.18. Remember, it takes seconds. 180 milliseconds. Let's just confirm that core.wait does take seconds as its argument. So core, just click on that. We then run down here while that's loading. Core.wait. Went too far. Let's go to the API, reference menu API. I think that's psychopy.core 0.18. Core.wait seconds. Yes, okay. So it will take take seconds. And so we should be okay with this. I don't know how quick the interrupts are for core.wait or what the resolution is, but we should be okay here. All right, and so we're going to present it for 0.18 seconds. And then what we want to do is we want to clear the screen, because remember, we're going to present the fixation, present the stimulus, and then we want to mask it. We haven't written the mask yet. That's the next video. But we want to basically clear the screen quickly and wait for the subject to respond. And so we want to clear the screen. Now, if you remember, if we just win0.flip, it's going to flip onto the screen whatever's in memory on that window object. And we haven't written anything to the window object, so it should blank out. And then we're going to wait for the key press to be pressed. Okay, for the key press to be pressed. And so now here we should have some very rough timing. We're going to present the fixation cross, flip it onto the screen, wait 1 second. We're then going to draw our stimulus, and that stimulus is going to have the length, so it's a 36-degree visual angle. We flip it onto the screen, it then waits 180 milliseconds, and then we're going to clear the screen. Now, the frame timing of this, or the timing of this program might be a little off, because again, I'm capturing the same screen as what I'm presenting on. It's an old computer, so hey, bear with us. Oh, did you actually see that? It's going to wait. So it's going to do nothing until we hit F or J or Q. So if I hit Q, it should break out. Hey, the Q button's working. All right, let's run that program again. So again, it's doing whatever it wants to do right at the start. And then it's going to present the fixation cross and then the stimulus. Did you see that? I'll hit F, fixation cross, stimulus. I'll hit J, fixation cross, stimulus. Hit J again, fixation, stimulus. Hit J again, fixation, stimulus. Oh, wow. We have just created essentially the line bisection task. One very small aspect of the line bisection task, but we have a fixation cross that's black and it's in the middle of the screen. We've got our stimulus. It's the correct length for a 36-degree visual angle stimulus with the correct height, the correct line width, the correct timing. And we're also getting input from the computer monitor. I'm going to hit Q. I'm getting really excited here. We need to settle down, okay? Because all we need to do now is create our masking stimulus. That's going to be really cool. We need to create our mask, and then we can essentially just slowly finish off our experiment by doing things like randomize the order, I'll get some transected lines and bisected lines all in there together. All right. I've been waffling on for an hour now. I'm taking my time for a reason, so that hopefully if you're a new Python programmer, you can follow along and get some idea of how it is that we're doing this. I've skipped over a little bit in terms of while loops and how while loops operate, but there's a lot of information out there. And creating functions, there's a lot of information out there where you can build up your own acumen and your own skill on how to create functions. So it's some pretty advanced stuff that I have skipped over. And if you want some help with functions and how to create functions and how to call functions and create arguments for functions and stuff, let me know in the comments and we can take it from there, okay? So, exciting stuff. Next video, we're going to create the masking stimulus. It's going to be pretty cool. I'm going to have some lunch first though. I'll catch you then.